All right. I think we're now into our next session, which pretty sure is you and me, Bryson.
Yeah, as we say in the Army, no plan survives first contact. And just like any conference schedule, it does not survive first contact either. And so Ian Anderson, who is going to be on to talk about how to conduct testing from real world experience with operational technologies over at Oklahoma Gas and Electric, he couldn't make it, but you're not missing out. He is going to still work over the weekend to record it. So you will get to hear directly from him on his experiences with tying IT and OT together for a combined holistic risk assessment approach. So still coming, but in the meantime, you got me and Tim.
Yay! Oh, yeah, that's it.
That was great comedy, Tim. You deserve
Yeah,
the awkward pause. So what are we talking about, Tim?
that's a great question. I mean, this could be as an ask the audience. I think just general. We can have this as sort of a pre-run of our talk in a couple of weeks.
You mean the talk at SANS ICS Summit that we haven't written yet or even started an outline on?
Whoa. We had a CFP proposal submitted.
I don't remember it.
You wrote it, so
you know how many CFPs I do? All right,
yeah.
let's go find that CFP and see what we apparently I submitted. Oh,
Well, I think so. Everything that we've talked to today, though, really, I think the big thing is there's this divide when you're doing this like IT OT thing. And for those of you that aren't familiar with some of the terms, you have IT is your information technology and OT is operational technology. And so there's a little bit when you get into the ICS world, there's some amount of butting heads between people that want to treat it as, hey, these things are the same as IT devices. They need to be protected the same as IT devices. And so that's where you have a little bit of a culture clash, even within companies, with how you can work and protect these things. Because on one side of it, you have the folks that are, worried about ransomware and all of that. And they're like, we've got to be able to shut things down. We've got to be able to stop it. We need to be able to cut things off. And then on the other side, you tend to have a lot of folks that are like, well, this controls the entire power to the town or a dam that is crucial for all of these things. And if you just shut that down, lives will be impacted because people are either going to get called away. They're not going to have services they would expect. And there is the potential that there could be loss of life depending on who you're shutting power down to. Is it a hospital? Are those things something that are considered? And all of that is what makes this even more difficult when you're talking about how you want to build and test the way we've talked about with adversary emulation in an environment that has those types of contexts and that type of risk. So that's something that's super important. And also, this can be a little bit of a lead-in for Bryson, some of the work you're doing with the ICS Village and, being a co-founder of that. And I'll let you at least give a little bit of a spiel on how that's aiding in this.
Yeah, so for those of you who are going, should I tune into this? I promise you, we are going to ground you on industrial control systems and the fact that even if you think you're not in an industrial control system environment, you are. So I apparently decided I don't have enough free time, and I co-founded a nonprofit, a 501c3 called the ICS Village with Tom Van Norman, and we build critical infrastructure and take it around the world to educate folks on security. We have been mainstays at the RSA conference. Check us out in a week and the Sandbox in the RSA conference. But our big Super Bowl, I think, is at DEF CON, where we have an entire collaborative CTF and a number of hands-on exhibits. We've awarded 2 DEF CON Black Badges in the past, which I think is pretty cool. And then we have our own annual conference called Hack the Capitol. The next one is May 10th and 11th in McLean, Virginia. It's our 6th one. It is chock full of great folks. We'll get the link to you. You can attend in person and you can attend that one virtually. So that's going to be an entire deep dive of policy and different aspects. You can only go to the real technical deep dives in person. So we did those with Chatham House rules to allow folks to be able to share some cutting edge research in industrial control systems. So Industrial control systems, Tim was talking about at a high level. Your office, where you have your enterprise IT that you think about, well, that is based on electricity. I actually saw a joke the other day where, if you think about it, lights in video games also use electricity for real. I thought that was kind of funny. So, water to the building automation systems, the physical security of your building, things like hospitals where you're controlling actuation through being able to maintain pressure and temperature in environments. So there are all of these components around us that we take for granted that I like to point out. That's what underpins modern society. We have all this discussion about cybersecurity up here and helping modern business scale, but it's the critical infrastructure that we don't think about that underpins everything. And the easiest way that I like to illustrate how industrial control systems got so complicated is if you think about how power was generated, distributed, and transmitted, or transmitted and distributed in the right order, 50 years ago, it was one way. Large power plant, most likely coal, producing electricity and then shipping it down to the enterprise or the individual consumer to use. Well, that changed a little while ago, and we now have the ability with renewables to push energy in a bidirectional way. And that might sound like it didn't complicate things, but when you start to look at the physics of driving electricity in that kind of way to market generation and demand and pricing, it became complicated, and we needed to interject computers into it. And so now that we've computerized this infrastructure, just like we've computerized everything else in our lives, suddenly the cybersecurity risks of those interconnected systems increased exponentially. And this is why industrial control systems have become the challenge that they have. Now, that being said, for those of you who work in the IT world, you're used to a certain level of maturity and understanding. So let's kind of level set there. Jason talked about it where he had seen the old days where the audits were just like, do you have AV and a firewall? Well, that's because that's how young our industry is. Firewalls are 20 years old. Think about that. The concept of commercially deployed firewalls separating my network from your network is 20 years old. And so when we look at operational technology, there's kind of a lagging maturity, which I feel like 2015, 2016 is where it really started to take another level for them to be following what we're doing. Now, I'm not saying that in 2015 and 16 is the first time that the energy industry suddenly discovered firewalls, but if you look at the maturity, it's about a generation behind. And that's important because we have this same kind of challenge in IT, or I was talking earlier in the keynote about the value of security champions and purple teaming being a great educational and communication process for bringing in other functions. Well, we have this across this divide of IT, which is what runs operations, scheduling, business, and logistics, and then operational technology, which is actually producing whatever that enterprise's purpose is, right? If I'm a manufacturer, I'm making things. If I'm in a utility, I'm producing electricity. And so industrial control systems are the revenue operations of that, and IT is kind of the stand side to it. And so we have a cultural divide where that's where we are with the tooling and the process and the understanding between them to bring them together. And so having tooling doesn't solve culture. Purple teaming was a process that we helped create because we saw the ability to bridge the gap that we saw in IT red teaming with its ability to assure the rest of the business. Well, industrial control systems have the same kind of challenge.
Yeah. See, look at this. You're getting history. You're getting overview of the challenges in the space. And this actually leads perfectly into a couple of questions that people have. So I'm going to tackle the first one from the chat, which is what is our take on pen testing or purple teaming inside an OT environment? And this is where, so those are two different, I'm going to split those out, right? And talk about pen testing versus purple teaming in an OT environment. I think one of the biggest challenges and hurdles I've seen, whether it's pen testers or are doing any testing in an environment that has both, is that the way pen testers, at least, from coming from a bit of a background of doing pen testing, red teaming, and then moving into purple teaming the past couple of years, what I've seen is people like to fire things off and then see what happens, right? And that's something that there's the sort of famous, I guess, examples, or at least the that you run an Nmap scan and it knocks over a device that is going to be an ICS device, and that might be controlling something important. You don't really know, and so there's not been seen sort of a lot of deliberate testing in ICS environments or OT environments because of that concern and that risk that, hey, this is going to knock out the power, this is going to knock something out. And if you're a pen tester and you knock that out and someone's like, well, how do you fix it? They're not going to know. You're not going to necessarily know. You're going to rely on the device owner who is going to say, why did you do that? And in a lot of cases, so this is where we start getting into ownership and how like utilities and devices work. There are sometimes, if you have a small enough group, that the people that are doing operation of and running like a power plant or something like that, they don't actually own or mess with any of the devices on their network. They call the vendor for that. They're going to call the vendor to come do updates and check in on the status of things. They really only have, you know, to draw in a parallel here with IT, this would be the equivalent of you only have access to a SIM, but you can't actually respond to anything. You don't actually see any visibility outside of that because that's sort of your world. And so that's what makes it really difficult to have some of these conversations around it. And I'll draw it back here to the tests that I think that can be done and are important, and this draws into purple teaming, are looking at this not from a how are we going to exploit or throw some sort of different attack at an ICS or OT device or environment, but looking at what are the use cases that already happen is sort of that. And I'll, you know, pen testing, red teaming, we can argue where the split is in that, but it's using the services that already interact with that device and using them to show that, hey, I have access to this device. And most of the time, people don't need to be told about the impact that could happen if you send something bad. And so sometimes proving that connection, right? Proving something like a ping, like, hey, I have access to this bridge device, this thing that's like an HMI, which is a way for, which is oftentimes a Windows machine that is sort of an interaction between your IT networks and some of your OT devices. So that is something that when we're doing purple teaming or testing with that, building confidence in what you're doing, the tests you're doing and why it's important. Part of that is building confidence in the folks and the things you're going to be testing on so that they are going to be okay with either accepting a level of risk that if you are doing the test, or at least having all the people in the room. So if something does go wrong, that people know how to tackle it quickly.
So Chris Peacock threw in the chat the Purdue model. And for those of you who aren't aware, the Purdue model is commonly kind of the reference enterprise architecture for industrial control systems. We break it down from a threat perspective, and I'm actually going to put the link in here from Megan Samford, who is on our advisory council. She is a vice president of product security in an industrial control system vendor. And we simplify it down to there's three pieces, right? The top, IT, which we all know and understand. And then where Tim was talking about HMI, human machine interface, that's what we call the beachhead. So IT is the most common threat vector. If you think about it, while there will be examples of industrial Internet of Things or industrial control system devices that will be Internet accessible and discoverable on Shodan or Census, the most common threat vector is through the large, squishy enterprise IT group that's out there. And the attacker comes in and then they pivot through to what we call the beachhead. And the beachhead are the HMI, the human machine interfaces, which is essentially a machine that allows me to manage and diagnose all of the connected operational technology devices in one go. DCS, a distributed control system, so a higher level system that is managing all of these pieces. Safety instrumented system, which is going to be looking at the tolerances of these devices, because these devices, which are the consolidated level 3, the bottom part there, they're pretty dumb, right? You've all heard of Stuxnet. It's now been 0 days since Stuxnet's been mentioned, and that was against something called a programmable logic controller, which just is a very simple device that's meant to survive under certain temperature, vibration, harsh environment conditions to affect some simple physical implementation in the world. Like, I'm an actuator that just does this. I go like this. It's all really simple, actually, when you get down to the bottom of it. But these devices are dumb. its whole point is I'm just taking a command from up above and I'm doing what I'm supposed to be doing that leads to some function within operational conditions that output is what I think it's supposed to be, and it all safely produces that. Well, the reality is I don't need to program or I don't need to build malware explicitly for those devices. I just have to target those high-level devices, which, as Tim said, are typically going to be older generation Windows and Linux boxes. This, of course, always prompts the IT professionals to go, well, just patch those, right? Are you kidding me? It's running Windows NT 3.51. Upgrade that. Well, you can't. You literally cannot do that. The devices cannot be upgraded for lots of different reasons. And so you're stuck with devices that were built with a 20 to 30 year life cycle, running unpatchable software and that even the easiest, like what was it, like the Melissa virus from 20 some years ago would still work on. And they are the things that control everything else. They tell everything else what to do. I don't need to do anything other than to get there. So from a how do I tie this into my risk assessment framework? For the lower level devices and the specific pieces, even at the beachhead level, that's where you want to use penetration testing. Now, I'm not going to do that in production because I can't potentially affect operation, but it's the kind of thing I can take this in a lab and I can look at understanding how I can harden the individual systems themselves. Now, again, I commented earlier that we have this challenge in penetration testing where we tend to think of systems in isolation and not the interconnected nature. Sorry, internet comes right out instead of interconnected nature of these devices. And very much in industrial control systems, it is a system of systems perspective that I need to be looking at because they have lots of individual system risks, those vulnerabilities that we talked about that I cannot directly mitigate. So I have to figure out how do I mitigate around them. So some examples of that are like software-defined networking. Okay, I can control the traffic and the protocol work around the devices, and I have this control plane of being able to do that, where I can basically implement kind of the shrink wrap layer around, I mean, I just made that up, but kind of, I think, fits as a metaphor, shrink wrap layer to mitigating things that I can't address directly. So that's kind of my recommendation where pen testing fits into this. And then with purple teaming, I'm able to look at access and impact, but simulated impact. So I can look at starting from how I get into IT to an assumed breach perspective, either way, how would I laterally move? Because there are going to be, again, an air gap is not an air gap is not an air gap. There is always a way into the operational technology network at the high level that I'm looking at. So understanding those choke points and being able to understand what are the behaviors that lead to an attacker that might be a low-level ransomware gang that's not going to get there versus somebody who is trying to pivot through that point. And there's really a limited number of ways that they're going to be able to do the discovery, the lateral movement, the potential escalation, and then getting to that to cross over. So being able to train the detections at those points, making sure that my jump boxes are well defended, and again, have that monitoring and overwatch built at that level. And then from there, I can simulate an understanding of what the impact would be in the production environment without actually driving impact, because we're not trying to do what the adversary would do. We're just trying to understand it.
Well, and if all of that Bryson just mentioned sounds like a lot of expertise for one person, then you would be right in thinking that this is a great opportunity for a purple team where you bring in your IT, OT folks, get everybody in a room, and it's going to take some time to figure out how do we move forward with some of this stuff. And it's going to take longer than you think it is. This goes back and sort of ties into our theme the whole day. As you're building momentum for doing these things over and over again, it is going to take time. And that's why when we're talking about sort of that state of the space, as Bryson mentioned, sometimes places being almost a generation behind when it comes to technology. Like if you thought trying to look for vendors for whatever your IT specific problem is, go and try and find vendors for OT specific. I mean, the example I give here, we've called out the attack evaluations and things that have been done. Actually they did a test for ICS, and instead of I think like attack evals for enterprise now is probably up to like 30, I think, or more vendors that participate. Attack evals for ICS had 5. That's it. 5 vendors. You've some names you've heard, some names you probably haven't, but it's a much smaller and it's a much different area. And so when you're talking about mitigations or things like that, that's going to be really tough. And one of the examples that I think Bryson brought up, and we do have here a question related to it, is hospital systems, right? And how do we deal with technology that is going to be old, that you have to keep around, or for some reason there is a reason to do it? Like, how are we going to do these things? There's a couple of different ones. I'll let Bryson weigh in a minute, but I did want to at least give an example here of not directly security related, but an interesting approach. So Disney World has all of these animatronics, right? They've got their sort of live robotics groups, and they had some technology that they really liked, and learned this in a behind the scenes tour. So it was kind of an interesting thing. They actually bought, they figured out how often they were going to need to replace a certain motherboard. And it's for a company that no longer exists, but they bought, I think it was like 50 years worth of those boards after they decided to implement it, so that even when it breaks, they always had a replacement, even though the company does not exist anymore. And so obviously that's probably not the way you're going to want to decide to protect maybe your medical devices. It's just an illustration of how some people that are trying to implement things that are going to take a long time, and Disney's got a lot of, we'll say, time, money, and expertise, and even they decided we're just going to keep this system because it's worked for us. There's no reason to spend more time developing a new one, even if maybe there is something that would work better for them now. And so I think hospital systems are right now trying to figure out between that risk versus how do I update things. So Bryson, anything to add on that?
Yeah, I'm definitely taking a note that we should bring in somebody from the medical industry to talk at the next UniCon. We have several customers that are in that space, including a medical device manufacturer. And I can tell you that's where part of the challenge starts. I've been, even before I started SCYTHE, I used to give a talk, which started with Internet of Things. And a lot of the principles that I was pushing actually just came out in the CISA software liability report. So that feels pretty good that those ideas are getting somewhere. But the starting point was that it is impossible to design 100% against vulnerability. Giving credit to the Zatcos, so Mudge and Sarah, I forget what CITL stands for, but they did an analysis where they were looking at these kinds of embedded devices and what were the common features that had a correlation to some level of defense. And that was sort of seen as the best approach of, like, put these features in and we know that has an indicator. My point being is where I saw the real value was beyond design, is how do we design for operation? And what I mean by that is vulnerabilities are going to happen, and making sure that these manufacturers have public points so that those can be disclosed and understood, because we, the security research community, really are trying to help. We're free quality assurance. Why wouldn't you use us? The second part, then, putting requirement that there is a certain time frame for those kinds of responses. And then most importantly, and I think this ties to each of us as individual citizens and consumers, along with places like hospitals that struggle with this, is where patches are available, making that a lot easier in designing for the patch distribution and inclusion. Because you can't, similar to where Jason Thomas was talking about how he had to take his law firm off and the amount of money that's lost. Well, that's the same thing for hospitals, only not only am I potentially losing money from a revenue perspective, the delay in certain procedures increases morbidity. So people die when there are these kinds of things. And so patch maintenance and having that be as easy as possible for where I can manage that kind of vulnerability management directly with systems. And then, of course, like I was describing in the higher level generic industrial control system environment, being able to manage around the vulnerability and mitigate the risk that way. Because there's a lot of times where that, again, the CAT scan machine, I'm never going to be able to take it offline. I'm never going to be able to update it. It's running Windows CE, and that's it. So you got to really work around those things. But I think we should bring somebody from that industry in next year to talk about that, because clearly there's a lot of interest.
Yeah. Well, and especially just seeing impacts of either ransomware or things like that are really starting to look that's something I think we've seen more and more, is that as everyone's been targeted, and we've seen more hospitals and things like that targeted, even not even just for just trying to ransom them, but for the data that they hold, right, can be very valuable. And so that's something I think it's a good thing that we're seeing more questions and comments and asks around like medical devices, medical device manufacturing.
So somebody found the link to my 2020 talk. There I am with the COVID beard. I was being funny because ICS, medics. I thought that was pretty clever. I think I'm funny. My mom tells me so. And so with Janine Medina, who is the one of the founders of the Biohacking Village, she helped me because I was at this time a few years ago not as familiar with the hospital and medical system. So here you get like a purple teaming approach to presentation on the fly, where I had put together some basics walking through an industrial control system overview of a hospital environment. And then I had a professional who was grounded in the industry to help steer it so that it would be valuable for everybody. How do I stop sharing? Oh, there we go.
When I started working at SCYTHE, Bryson had that beard. That was I think the first time I had seen you in like 2 years, and then it was the full beard. So, but yeah, that's all right. Let's see.
Yeah, I'm trying to see if there's more industrial control system pieces to the question about Gandalf. That was the origin of Cyber Gandalf. For those of you who are not aware, I do a lot of different characters. At that time with hair, I had the opportunity to take those characters in a lot of different directions. If you really want to go the deep dive on that, the end of my Olympic level COVID beard and hair growing, I did a charity fundraiser telethon with Ron Gula called The Great Shave. And I came out in multiple characters as I shaved down in between with a panel talking about things. And then I would answer different questions and discussion with the different characters as best as I could. The whole thing was made up, was improv. If you remember, COVID was kind of a crazy time. That was definitely a crazy video.
Yeah, I think Chris put it in a link in the chat for everyone.
Okay, there is me, a little chubby during COVID, doing the Cyber Samurai. Let's see. Oh, yeah, this is Drunken Pirate. Funny story about that rum, because this, like I said, this was all improv. So I hadn't really thought through all the characters. And I quickly asked one of their sons who was running around the back of their mansion, because he's well off. And I was like, hey, I need a bottle of rum. And of course, I figured as a pirate, I should swig my rum and pretend to be drunk. And Cindy Gula made the comment. She's like, that's like a $5,000 bottle. I was like, oh my God. Yep. And then the final character, this is Lord Cyberbottom, who I modeled after a 19th century railroad tycoon. He's completely ridiculous in his approach to security. Thank you, Chris.
There's a lot more in that video. So that's
thank you. That was so that stash. I had always seen like hipsters doing the like rolled stash thing, and I figured it wouldn't be too hard to oil it, and like it would roll up, and it didn't work. So we actually ended up gluing it to my face. This has nothing to do with industrial control systems, but if you're entertained, we're happy to do it. Yeah, I know stash wax is a thing. I had mustache wax. I did do some prep for this.
Bryson was trying to embrace that hipster. Try it.
Yep, it was all improv. I'm not a hipster though.
You heard it here first.
I don't think I'm not a hipster.